Welcome to the Small Wall Podcast.
This is the small wall. This is the small wall. The small wall. நான் கெட்டு போன குட்டி சுவரு. இதுதான்.
Your name's on the pink slip. You are in the small wall. They had no goodbye. You are in the small wall. Rat stopped working. You are in the small wall. Security walk first. You are in the small wall.
Hello, everybody. This is Shrikant Devarajan coming again with a podcast. And today we are going to see something again with Agentic AI. We are going to talk about evidence-based medicine. So let's quickly jump into the podcast and try to understand what we mean by EBM and how does Agentic AI help us here. So what is evidence-based medicine, EBM? It is a systematic approach to clinical problem solving. It combines the best external research with clinical expertise. It blends evidence with clinical judgment. It recognizes the importance of applying evidence in real-world patient care. Respects patients' values. It aligns decisions with each patient's goals and preferences. The structured decision-making process. It involves asking focused questions and finding and appraising evidence and applying it thoughtfully. It improves outcomes, aims to deliver the most effective care through reliable, up-to-date evidence. It is very adaptable and transparent, provides a framework for continuous learning as new data emerges. So, evidence-based learning is the practice of making clinical decisions based on the best available scientific evidence combined with clinical expertise and patient preferences. So right now, these applications are keyword-based searches, right? They use keyword matching and give you the result. And often, I have seen applications that gives back weird results. For example, if you go and search for diabetes, right, these kind of results seems to appear. I have seen some applications like that. I'm not even joking here. As soon as you put the word diabetes, you're going to get top 10 natural remedies doctors don't want you to know kind of things because these are driven, sponsored by algorithms, and it's not driven by evidence. So you need to remember the traditional keyword searches will not work here. The reason is the input, the corpus that we build from the raw input is really complex. And the keyword search will never work here because it's not going to understand the terms. So let's see some of the reasons why it doesn't work. The keyword search completely ignores the intent. It doesn't understand why the user is searching. It can't tell if the user needs a meta-analysis, case study, or whatever. It doesn't know. It was just going to do a match. There is no semantic understanding. It relies on exact word matches, equal to sign, this equal to this. It missing synonyms like myocardial infarction versus heart attack. Yeah, they are all similar words. It doesn't understand that. It doesn't capture the meaning or the context. And one of the biggest issue in medical is terminologies. They are not equal across. It'll vary. And the medical text uses a lot of acronyms, a lot of abbreviations, and phrasing too. And if you go across English language itself, the UK English will use different spelling, while American English does use different spelling for certain things. So the terminology variability is an issue. And traditional keyword search struggles with complex clinical questions. The reason is because EBM is as whenever somebody is going to inquire about evidence, they're going to ask multiple things to you. And keyword search will struggle and it is dramatically slow too. As the search complexity increases, there it will become really slow. And the keyword search doesn't understand the quality of the output. It just matches terms and it's not rigor. It doesn't know if it is a weak study or a strong study or a real authentic input or something like that. It is not going to know. It lacks contextual awareness, as we already spoke about.
You are in a small wall.
Not a stage, not a throne, just a random old ledge where genius and nonsense teeter on the edge. Tech talk, beat drops, deep thoughts, bad jokes, smart enough
So now let's look into technical solution quickly. And this is where the most interesting agents are operating. So we begin with the raw inputs. These raw inputs could be in heterogeneous formats. They could be PDFs, they could be docs, they could be images. They are completely unstructured clinical evidences. I can show you an example of those documents. So here's a document and a good example here. This is type 2 diabetes in adults. This is from NICE, and you can see the guidelines here, and it is structured beautifully actually, and you can see some good way of looking into it. Gives you medicine, what kind of medicine, etc., etc. I'm not a doctor, so I don't know how to read this, but this is what it is. But now I'll show you one more. Let's take diabetes in children, type 2 diabetes in children, similar document, but if you see here, the structure has changed completely. And this is also from NICE, and there's a lot of research, and they also tell you which year these things were discovered or amended. So this is the structure that we need to ingest and then build our corpus. So you just saw the example of the document. So step number 2 is corpus builder. Now that you have the raw inputs, we are going to take it and build a structured JSON with knowledge chunks with metadata. Very straightforward. It's a well-made JSON structure. And we take the next step is we take the JSON structure and build embeddings and a vector store. And I use FAISS and Olama to do this. And as soon as the vector store is ready, we hand it over to our LangChain pipeline. And the LangChain pipeline will do the retrieval generate. It will get information and it will retrieve and build the evidence and hand it over to the client. It's a very straightforward agent, and the LangChain is the orchestrator for all this. Maybe when I will explain you when I show the source code. So this is a very simple architecture. When using agentic AI, this is the result you're going to have generally. So when you go and search for what's the first line treatment for type 2 diabetes, the result is going to be very clear. The first line medication for type 2 diabetes is metformin, an oral drug that reduces blood sugar levels. And it gives you the research name, the researcher here, and it also tells you an update and which year it was amended. It'll give you a lot of information, and we can go and dig into it and we can view the source code. I'll show you in the demo once we are there. So let's now quickly explore my source code. I have a backend and a front end, and we'll not talk about the front end. It's pretty straightforward. The backend, right? If you look at that, we have data, we have a RAG engine, and we have a vector store, and we have a static thing. First, let's open the static. The static folder has all the raw data that I spoke about. So let's quickly look into the structures of them and how do they look. Okay. So let's take type 2 diabetes in adults. As you can see, this is how the structure is. Clearly, they talk about the condition, they give you the guidelines, and they give you a lot of evidence behind it. What kind of medicine and what kind of risk and other things. These are from their own researchers. And this is one. The beauty is the next one, if you see, uh, take this diabetes in type 1 children, the structure dramatically changes. As you can see that it's a big document. And as I told before, these are written for compliance as they give you the year and which year it was amended, and a lot of things are here. So this is the raw input I spoke about. So we take the raw input and we go into our RAG engine. And RAG engine is very simple. We have a loader which loads, prepares text chunks from these static files. And then we have the embedder, which will convert those chunks into vector storage, save it somewhere, which you go and see it is saved in our vector store here. And the retriever will search for you the relevant chunks that uses AI to answer. Like we use Olama to retrieve it and answer. That's where the RAG is about. So let me open the retriever. As a retriever, you can see this is the RAG engine that uses LangChain. As you can see that I'm loading the vector store here, and then I'm using LLM. And here is the my line chain, QH chain that retrieves it. And this is the prompt that I use. We can make this much more interesting, but to keep it simple, I just wrote the prompt. And this is the result, and this is where the result comes in question, answer, and the sources. Very straightforward line chain retriever. And these are the things for files and vector stores where we capture the vectors here. And now let's look at an working application quickly. So first, to run the application, I need to run the Olama server on my Mac here. So the Olama server is starting now. It's a local LLM. Give it few minutes. Maybe it will start pretty quickly. And with that, yeah, it is ready. Now I'm going to start my backend and let's run Python dot. It's running it, and then I'll begin my front end. So this is where application is. Apologies for not coming up there. I just wrote a very simple application where I have got departments like endocrinology, pediatrics, and also I can run the builder corpus here also. If I need to rebuild the whole thing, I just need to click on this. And, it's going to rebuild the corpus. So I can go back and see what is happening there as it's building the corpus here. This is Olama doing it, quickly rebuilding it. The corpus has been rebuilt. And let's go into type 1 diabetes. Just for sake of convenience, I made up questions. I don't want to enter each time. When developing an application, I just do a drop down. So we can take the first question: what is the recommended first line treatment for diabetes? Just ask the question, and it's going to run the line chain and go back to Llama and come up with a very good report. It takes a few seconds since running for the first time. As you can see, it is running there. Went back here. There you got the results. It clearly says you the recommendation of first line diabetes insulin therapy, and it gives you the documents where you need to go and see. Sometimes the indexing it gives you very clearly.
You are in the small wall. You are in the small wall.
Hope you enjoyed the podcast. I love doing Agentic AI and other AI stuff. But in the next podcast, I'm going to change a little bit. I'm going to go back to music. And I'm also going to talk about my AI vocalist that I recently employed in some of my compositions. And we'll take a look at that. We'll show the tracks and how the music is made. And I have a brand new song that's been sitting in my hard disk for some time now. Please subscribe to my channel. The YouTube algorithm gods needs those kind of appreciation. Please do that, and I would appreciate it. Thank you very much. Until then, Srikanth signing off.
You are in the small wall.